A pointer is just something that tells you where to go. If you're on a highway, you might have seen one of these signs. If you go this way, you'll reach this city. If you go this way, you'll reach another city. Same thing with the index at the end of the books. It's just something that tells you if you go to this page, you'll find this word. Or if you're old school, if you remember one of these dictionaries, it's one of these things on the side that tells you where certain words are. A pointer, in a similar sense, if you have an int pointer, I'm just going to call it int pointer. This is just something that says if you follow this, you're going to find an integer. It's just like reading directions on a map. It tells you where to go. In terms of what the book says, a pointer is a reference type. A reference is just something that stores an address. If you're confused about what a reference is, I suggest checking out video number 13. But don't get confused by the words, references, pointers. Again, it just means that if you follow this, you're going to find an integer. Now, to answer one of my own questions that I had when I was starting out, let's consider the question, why do we use pointers in the first place? And let's say in a game you have an axe. You're swinging your axe, you're trying to hit the enemy. What you need to understand is that even if this were the entire game, you're not going to be able to build this without pointers or some sort of reference types. Let's say you're going to swing the axe. You're going to swing the axe from here to here. It's going to have a bunch of animation data with the keyframes here. Something like this. Each of these keyframes tell you where the axe should be or the rotation of it. The axe or whatever is controlling the axe is just going to follow the path. The question is, how does the axe know where to go? Well, you're going to have some sort of an animation data somewhere stored on your memory. The axe is going to have a reference type that says, if you go here, you're going to find the animation info. So the question really isn't why. The only thing that's left is how and where. You might also have some collision detection code. And let's say you have a function that takes in the axe position and the enemy position and gives you the info like whether the axe hit the enemy, where it hit, etc. Usually in a game, a collision would require a lot more than this, but for simplicity, let's just say that this little function takes in some sort of a reference type that tells you where the player info is, as well as where the enemy info is. You could use a copy of the info rather than the reference. Check out video number 13 for that. But usually a function needs to know where to find the info. So even for a simple game like this, you're going to have a bunch of reference types. It's just like finding some place in a city. You look at a map and it tells you where to go. Now, when and how to use pointers, it gets a little more complicated. You're only going to get the knowledge and experience from going through trial and error as well as reading other people's code. That takes years. But again, fundamentally, it's just an address. Later, I'm going to talk about stuff like dynamic memory allocation, smart pointers, and all that. But for this video, let's just focus on the real basics. Let's say I have an integer, some int. I'll say it's 5. I'm going to say cout integer value. Get the value from some int. Let's also get the address of the integer address. And for this, ampersand, which means address of some integer. I'm going to run this, F5. We now know that at this address, we have a bunch of ones and zeros that says 5. Now I'm going to say int pointer is going to point to that integer, the address of that integer, and I'm going to say int pointer. Let's look at int ptr, F5. Okay, we see that the value of the pointer is the integer address. The pointer itself is also a variable, so I can say int pointer address, and we can get the address of the pointer itself. F5. Now this is where the pointer is stored. This is the value, and that value equals the integer address. If we try to draw this, let's say you have some memory block, and in that memory you have a bunch of ones and zeros that says 5. This memory block also has an address that looks like this. You have another memory block. Now this block has a bunch of ones and zeros that says this. which equals the address of this block. It has its own memory, of course, something that looks like this. So let's try debugging this. I'm going to put a breakpoint at the end, run the debugger. For the watch window, I'm going to say address of some int. I'm also going to look at the memory of int ptr, address of int ptr, 1 byte integers, int 4s. So this is the memory for the pointer, and it literally says D7 FE B0, which is the address for the integer. And let me introduce one more thing here. We have something called dereferencing. I'm going to say int pointer dereference. And for this, I'm going to use this syntax, asterisk int ptr. When you use this syntax, putting the asterisk in the front, it means we're going to look at the value that it points to. So if I run this, F5, and here we get the result, which is the value of the integer. But this is all it is. Are you going to look at the address or the value that it points to? It's just some value stored in some address. Try debugging this yourself and understand what it looks like on your memory, and later I'll talk more about pointers. And that's it for this video. If you have any questions, you can reach me on my Discord server. I have all the links below. Thanks for watching. I'll see you next time.